Okay, today we're going to look at function notation on the TI36 Pro calculator, and it's nice because it handles function notation really well, which is quite handy. So we're going to look at the slope of this quadratic function right here. Negative 5x squared plus 20x plus 1 could be a ball going through the air, typical projectile function, and we want to get the slope of this curve because we know, even in grade 10, we know that the slope is changing from 1.9 to 2. And so we're going to say, you know, is it really steep? Is it not so steep? And thinking about questions like, if it's really steep, does that mean the ball's near the top? Or does that mean the ball's getting close to hitting the ground? Those sorts of things. So we're going to calculate slope with it, and we're going to use function notation. So the first thing we need to do is we need to get that function in. What we do is we press the table button. I just have to reset my camera. There we go. Don't know what's going on here. There we go. It should come back on. And sorry, folks, about that. Whoa! There goes my camera. And we will set that back up again. There. That's not so bad. We got it back on. Okay, not a very good start. So what we need to do is we need to enter the function. So what we do is we edit the function. So we come in and we clear whatever's in there, press the clear button, and that gets rid of it. I hit clear one too many times, so I hit table. I go down to edit function and hit enter, and now I go over one and just hit clear, and that gets rid of it. So now I can enter in my new function. F of x is negative 5x squared plus 20x plus 1, and hit enter. And I'm not going to really worry about a table of values right now because I want to calculate the slope. So what I do now is hit second and quit. And now I want to get the slope. And so since it has what's called math print, I know that my formula is y2 minus y1 over x2 minus x1. But since we're in function notation, it's f at x2 minus f at x1 over x2 minus x1. And so the nice thing about this is all I need to do now is I can press the table button here, and I hit enter, and it gives me f at, and I just sub in 2. So f at 2 minus table, hit again, f, 1.9 bracket, and then come down to here, and I just do 2 minus 1.9. Now the benefit of this, of course, is that it's far less in terms of work. You don't have to actually substitute all your values into the equation. So it's quite a nice clean way to do it. And then I just hit enter, and I've got my slope is 0.5. So that's it. The slope is 0.5 at that point. And that's not very steep, right? So our slope is 0.5 at that point. Okay, then it says, the second part says, use guess and check to find the second x-intercept. So, the one that's furthest to the right. If it was a ball going through the air, thinking of it like this, when the ball hits the ground, right there. So one of the ways we can do that is we can just use our function notation again, table, f. And I'm going to guess for f at 3. What's that? Oh, it's 16. So then I'm just going to go back up with my arrow there, hit enter, and then change that to f at 4. F at 4, it's almost hit the ground. It's at 1. Okay, so I just go up, up again, hit enter to edit that, and I'm going to try 5 seconds. Okay, so it's gone through the ground, so that's probably not a good thing. So now I go up, up again, hit enter, and I can get it at, say, 4.2. Hit enter, and negative 3.2, up, up again. You can see I don't even have to close that last bracket. 4.1. Hit enter. It's negative 1.5. Up, up again. 4.05. Hit enter. Whoops, I'm not sure what I did there. Oh, I can see now what I did. So I hit delete, 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 and 4.05. What does that give us? There you go. So it's basically 4.05 seconds when it hits. So that's the way you use function notation. And if you have to do a number of calculations, function notation is usually a really good thing to work with. So I would encourage you to work with function notation. One thing that you can do, and I'll show you right now, working with function notation, we can actually go into the solver and use it. So I'm going to go use that numeric solver, and so I can hit clear to clear that equation out, and now I can just go table f at x, and I type in x bracket equals 0, and that'll tell me when it hits the ground, right? F at x equals 0. So instead of rewriting the entire equation, I can just have f at x equals 0. Hit enter. And for this one, I'm going to guess at this one because I knew it was around 4. So I'm just going to type in 4, hit enter again, and it's going to tell me the exact value. Oh, look at that, 4.04, 4.049. So 4.05 was very close. Okay, but if you notice there, all I had to do was hit f at x, and so that's a nice feature as well. And you can do a variety of things with the f at x. You can actually do your transformations that way. If you, for example, so if we had that function, I'm just going to quit. Another way you can do it is I could do what is double the function, and I hit table f at x, and I could do a vertical stretch by factor 2, and then a horizontal compression by factor 3 of that function, and bracket, and then what if I shifted up 5 and hit enter? This might give me 982, because right now it actually has a value stored for x, that x of 4 point whatever. But anyway, you can see now that you can actually do transformations as well. Not that you'll want to, not that that makes much sense to you right now, but I just wanted to go through that with you. Okay, so that's how you use function notation with the TI36x Pro calculator.